We have already discussed the memory system in computer organization. We know that a general purpose computer should also be able to communicate with a wide range of I/O devices too. So at a time, the processor may be trying to communicate with the memory or with the I/O. So how can it distinguish between the two? When the processor needs to communicate with the I/O, how can it access it? Or when it needs to communicate with the memory, how the memory can be accessed? One way is to use a separate communication bus for the memory and for the I/O system. But the most common approach is to use a single communication bus for the memory system and for the I/O system. So with a single bus, how is this possible? One approach is to use a separate instruction set for the I/O devices. Hence, the instruction from the processor itself specifies whether it is an instruction for the memory or whether it is a command to the I/O device. When the processor issues an instruction, it will be decoded. The corresponding address will be kept on the address lines. If there is data, it will be kept on the data lines, and the control information will be kept on the control lines. And since we are using separate instruction set for I/O, we need separate control lines or additional control lines for I/O. If this is an instruction for the memory, one of these lines, memory read or memory write, will be active. If this is a command to I/O, then one of these lines, I/O read or I/O write, will be active. Hence, use of separate instruction set implies use of separate control lines. So here we treat the I/O devices entirely different from that of memory. We use separate instruction set for them, and hence we use separate control lines for them. Also we use separate address space for them. Let this be the total addressable memory. For the I/O devices, we use another set of addresses. We never use any of these addresses to identify the I/O devices. Hence, this is called I/O mapped I/O or isolated I/O, in which the I/O devices are completely separated or isolated from the memory and they are treated in a different way. And the other way of mapping is memory mapped I/O. Here, the I/O devices are treated as a part of memory. We never use separate instruction set for I/O. Common instruction set for the memory and for the I/O implies same set of control lines for both the memory and the I/O. Also, no separate address space for memory and the I/O system. Among the total addressable memory, a range of addresses or a portion of addresses will be assigned for the set of I/O devices. And hence, this sharing of address space itself will help to distinguish between the memory and the I/O devices. Because a range of addresses will be used for the memory and another range of addresses will be used for the I/O devices. So if the processor is issuing a command with an address within this range, it means it is a command to an I/O device and that I/O device will be alert. And if the processor issues an instruction with an address within this range for memory, it means it is an instruction intended for that memory location. So if the processor tries to write to an I/O device, it will write to the memory location corresponding to that I/O device within this range, and eventually that value will be written to the I/O device. Similarly, to read data from the I/O, the data from the I/O will be written to a corresponding memory location within this range, and eventually that value will be written to the memory. So everything is done through the memory itself. Hence, the I/O system is also considered as a part of memory. So here the instructions are common, the control lines are common. Also, they share the address space or the address space is common. Hence, we treat the I/O as a part of memory and hence it is called memory mapped I/O. Hence, in memory mapped I/O, the problem is among the total addressable memory, a portion is allocated for the I/O devices. Hence, the available address space is reduced. But this is a simple method. No additional control logic is required, but this is not much efficient. And in I/O mapped I/O, the total addressable memory is all available for use, and this is an efficient method. But here we need additional control logic, and hence this is not a simple method. Each method has its own advantages and disadvantages.